In this video, I'm going to walk through the where clause in the SQL language. Um, this video I'm going to split the lecture ultimately into two separate videos. And so the first will introduce the where clause. We'll talk through some basic types of logic, and then the second video will cover the rest of the PowerPoint, which really dives into more complicated logic, conditions, and then also one special topic related to working with logic and SQL. So diving in, you'll see the standard query that we've been reviewing over in the top right corner, right? But now we're focusing on the where clause, which follows the from clause. And it will always follow the from clause. And what does the where clause do? It tells SQL what elements or data that you want to exclude or include, or some combination of multiple criteria. The one important note is the second bullet here. So the filtering criteria is applied to records within the table source. What does this mean? It means that you're not ultimately, running your query, retrieving some data, and then SQL's performing the filtering on that. It's rather performing the filter. It's performing the filtering on the original table. And so what that means is within the where clause, you cannot use any column aliases. So if we were to rename city, right, with a column alias of city name, we could not refer to city name in the where clause because that column or field does not exist in the original table. So that's one important note with where. It's also going to apply to the group by clause. The only place where you can't, or you can rather, refer to a column alias is in the order by clause. And the reason for that is that SQL's already run the query. It already has the data kind of stored in memory. And then it's ultimately ordering or sorting the data that's already extracted from the table based on the parameters you've given in the prior clauses. Says, again, one important note is that you cannot use column aliases in the where clause. And so an example of the where clause just in practice. So in this particular query, we're saying where state province ID equals 79. That means when the query is executed on the person address table, SQL will look at that table and ultimately exclude all records that are not 79, or conversely, SQL will actually include all records where the value of state province ID field is 79. The clause, in practice, you use the where clause all the time, and generally you introduce pretty complex logic at times. This is the filtering kind of. The where clause is necessary in analysis, and not just even in the SQL language, but really, filtering is one of your primary steps in data analysis. You ultimately need to clean, scrub, tidy your data, and filtering is one of those tasks. And so the where clause really uses conditional logic. So you're gonna write a condition, and it's gonna evaluate. SQL is gonna evaluate whether that's true or not. So in this particular example, where state province ID equals 79, our condition is that state province ID, that field, has a value of 79. And SQL is going to evaluate at the record level whether or not that's true in the original table source. And so the types of logic that you'll see in where clauses are equivalence and non-equivalence. So in the example we've shown here, equals is equivalence. You can also do does not equal. There are comparisons, so greater than, less than, or between. And this can be numeric data. It can be date data. It can be string data as well, but that's more for like text mining, which I've never really used that in practice, but SQL does support it. And then also compound conditions. So any one or more combinations of conditions, and evaluating whether, together those conditions are true or one of those conditions is satisfied. The other resource that I have at the bottom of the screen is a documentation for operators within T-SQL. The link, we'll see how this goes. Where is it going to open? So I'll bring this over. And so you'll see the MSDN documentation on operators. This is not just confined to logical operators, which you'll see are listed here, right? And so you have, your not, your and, your or, but the other portion that's actually used in these where clauses and logic within SQL are these comparison operators. So that's where others are listed. Going back to the PowerPoint, just diving into some examples with the where clause and how it works, and then also the various operators that you can use within T-SQL. The first is the example that we covered before. So on equivalence or equals, we have a clause where state province ID equals 79. So SQL will return records where the value for the state province ID field is 79. In the second example, we're using the in operator and supplying a list contained within parentheses. So we're saying where state province ID in 78, 79 is basically evaluating whether that state province ID has a value of 78 or 79. And this list can ultimately grow as large as you need it. And then there's also the non-equivalence. So if for does not equal, right? If we're trying to evaluate this first example here, and then ultimately negate it or filter out records with the value of 79, we use this symbol here, or these two symbols rather, the greater than and then the less than and then the greater than sign. You can also use an exclamation point and equals. This is kind of in. This is also used in R, I think, and perhaps some other languages. But in general, you'll see the first example in T-SQL because that's kind of the standard. And then looking at use with the in clause, there's essentially two ways that you could exclude records with the value of 78 or 79 for the field state province ID. You could say state province ID not in 78, 79, and that would be equivalent to putting a not, negating essentially when the state province ID is in 78, 79. And so that really covered numeric data. And then I'm going to cover strings, and then we'll hop over to SQL in order to see these in practice. So character data or strings is words or combinations of new character data. That ultimately in T-SQL, they are denoted with a single quotation mark. So you'll see where city equals Boston, right? This as an open single quotation mark followed by and closed by a single quotation mark. They're not double quotes in T-SQL, which is kind of different from most programming languages out there. The double quotations are ultimately reserved for or rather SQL treats them as though they are referring to objects. So a column name you could refer to with double quotation marks. So you'll see a lot of single quotation marks in a SQL script. You'll also note that SQL changes the formatting to red to denote that it's ultimately a string. So in the first clause, where city equals Boston, we're basically returning records where the value for city is Boston. And note that this isn't, if there's a space after it or before it, that ultimately would not be true for this particular condition. Then with the in operator, you can add additional equivalents in there or additional values to evaluate. So in this particular clause, we're seeing if the city is in Boston or Cincinnati. Those records are ultimately going to be returned from the table source, and then the rest of the query is going to execute on top of that data. In terms of non-equivalence, same exact way as with numeric data. So that you can, use the does not equal symbols, or you can say not in a particular list. Then you can ultimately have one item in this list as well. So as with most programming languages, there's a lot of different ways to do the same thing. So we're going to hop over to SQL now to kind of work through these examples in practice. Let me exit out of here. All right. You can ultimately close, right, the Object Explorer on the left. I did just to support kind of us working in here. If you ever needed to get that back, you could go to the view in the toolbar. Of course, I'm not. Object Explorer, which also has the hotkey F8. So if we bring that up, you'll see that it populates to the left, and you can ultimately close out of it as well. And so, as we discussed in the last a few videos ago, that you can set your current database through AdventureWorks. You can set your current database to AdventureWorks through the use keyword. And because your database name might ultimately differ, this is kind of useful because throughout the script, I no longer have to refer to the database name in any of my queries. So it saves a lot of work, a lot of typing. And so we're going to just execute that. It was already, I already had it run, right? The AdventureWorks 2019 was my current database, but you can see up here that it is set to the current database. And so we'll just go through the various examples we reviewed on the PowerPoint, on the person dot address table, which has kind of been the standard one that I've reviewed concepts with. And so in this particular query, we're going to return all records for all fields from this table where the state province ID has a value of 79. So we're going to execute that. And you'll see in the output window that the state province ID field, the value for every record that is returned will be 79. There are quite a few. It looks like, based on the number down here, there are about 2,600 rows within the original data that have a value of 79 for the state province ID. And the second, I did add an order by clause here just to sort the records, right? I mean, if we have, we're evaluating whether state province ID is either 78 or 79, ordering the results in ascending order would ultimately display 78 first. So we're going to execute that. And you'll notice that we don't have any values of 78 after they were sorted. So this means that there are no values of 78 in the original table for the field state province ID, and we can check that right by using the where clause. So instead of 79, we're going to use 78, and we should see no records returned. There are no records returned. So no values in the original table have, there's no value of 78 in the original table for the state province ID field. So looking at how this works in non-equivalence, or the negation of these various conditions, I did restrict it to the top 10 records for all fields because you ultimately get a lot more records. But when we evaluate this query, run it, we'll see in the output window that the state province ID has various values. But if we were to return all records, we would not find a record with a value of 79 for state province ID. And then again, you can use the exclamation point and the equal sign in order to essentially accomplish the same thing. You'll see the same records returned. It's equivalent. It's equivalent way to say does not equal in SQL. And then in these particular examples, right, we're putting a not in front of the N here, basically to exclude all records that have a value of 78 or 79. This accomplishes the same exact thing. We're just simply negating this condition within the parentheses. And so if I run these, I'm actually going to run them in parallel. And you'll see in the output window that it actually splits it, right? So we do have the same things in the two output windows. So you can see here, and I did order by state province ID. So you can see state province ID of 1 first, 6, 7, right? And if we go all the way down, or start to go down, right? Once we get to where 78, 79 should be, let's keep on going. Waiting for 80. There's quite a few. 77. Let's see if I can. More than I would have thought. Okay, keep on going. Oh, there it was. All right, so right here, you'll see 77. If they're if for some reason the logic wasn't accurate in the where clause, we would see values of 78 and 79 here. And then to show you that these two queries return the same number of records, you'll see on the record label or the row label on the first query versus the second, we have 16,000, roughly 17,000 records for each query. And then jumping into equivalence with strings, note again that string or character data within T-SQL has single apostrophes to denote that it's a string. And so when we run select star, where the city is Boston, you'll see that there's only one record in the table with a value of Boston for city. I didn't note this in the lecture, but T-SQL is not case sensitive with these searches. I'm sure there's a way to force it to be, but it is not by default. So I just change some of the capitalization. We'll see that same record returns. If you were ultimately to need case sensitivity for something like this, you could find that option to turn it on. And then in this particular example, we're basically returning records where the value of city is either Boston or Cincinnati. We could also add, right, because I only did two elements in the list for the N operator. We could add another one. I'm just trying to, I know this city exists in the table. And so if we run that query, right, we're going to now see 3 different cities returned. And then non-equivalence works the same way again as numeric data. I did restrict it to the top 10 records because there will be very many if I don't. You'll see in this particular example, they're all the same city here. We could open this up a little bit to the top 1,000 just to see that there are other values for city, right? That looks like Oakland at the top there, Richmond, obviously a lot of other values for city, but we will not see a value of Boston in the field city. Same goes for the Boston, Cincinnati, expanding the criteria to those 2 cities and excluding records where those are the values. Again, we're going to see or should see. Okay, so the results weren't as expected. So I did order by city in this particular example so that you could see various other city names, whereas in the first query, right, the first 10 records were all the same city. But if we were to go, scroll through all of these values, if we were to return all records and then go through the values, we would not see Boston or Cincinnati in this field. And that really concludes this particular lecture on the introduction to the where clause, and then some basic conditions with equivalence and non-equivalence.